So we're not going to be solving equations this time. These are not equations, they are inequalities, which means not that something is not equal to, right? So remember, we've talked about the inequality symbols before. Some of them. I don't know that we've hit all of them. It's these four symbols, and there's actually one more, the equal symbol with a slash through it. Remember that this one is greater than. Remember, it's always greater than if you see the bigger part of the opening first, right? So this one's is greater than. Remember, it's got to have that word is in it. Now, we're not going to be doing any translations, but you need to practice getting it right. It's got to have the word is in it. What's this one then? Is less than. There you go. What does just the phrase less than mean? Subtract, right? Okay. What does just the phrase greater than mean? Add. You betcha. Good. Now, these are the ones, I don't know that we've talked about. They have a little bit of the equal symbol in them, right? So they give you two choices. Is greater than or equal to. Good. Okay? So is greater than or equal to. This one is less than or equal to. And finally, this one is not equal to. Okay? All right. So these are the inequality symbols. What's the equality symbol? Just the equal symbol, right? There you go. Good. But there are several inequality symbols, only one equality symbol. And what we're going to do today is we're going to look at solving inequalities. Now, these are not going to get too carried away when you're solving these, but I'm going to tell you that you already have almost all the information you need to be able to solve these. Because they're not equalities, but they're inequalities, but they're very related. They are solved using exactly the same steps as equations. So, if they're solved using exactly the same steps as equations, then first thing you look for are parentheses. What do you look for next? Be careful, that's order of operations. Yeah. Fractions or decimals. There you go. What next?
Like terms.
Like terms that are on the same side. Good. Then you ask yourself what kind of equation they are. They're linear because you don't see any exponents. So you need to get all your what? Variable terms on one side and all your what? Number terms on the other side. And then simply divide both sides by the coefficient, the number in front of the variable. All right? Boy, kids. If you can't quote it back to me, you don't know it. Now, I know some of you just don't want to speak, but that's fine. But you've got to be able to quote them back to me. As I ask them, you better be able to, because if you don't, then you don't know it. Right? Okay, well, that's some people just can't or won't, so that's okay. But you better know it well enough to have that in your head at the very least, right?
So is that it's parentheses,
okay.
Fractions or decimals?
Fractions or decimals.
And
combine like terms that are on the same side. Then get all your variable terms on one side. Get your number terms, variable terms, the ones that have letters in them. Right? Then the number terms on the other side, and then divide by the coefficient. Right?
Coefficient?
The number in front.
Is that like
the number in front? Like if it's 4x, what's the coefficient?
X.
The coefficient is the 4. There you go. Okay. Now, the only difference, because these are not equalities, they're inequalities, they do have one difference, and it's always the last step. So on the last step, and what is the last step? Divide by the coefficient, okay? So the last step. If you divide by a negative number, okay? by a negative number, you must reverse the inequality symbol. So if you divide by a negative number, you must reverse the inequality symbol. Now, there are a couple of things about this that I want to talk to you about. Does it say if you divide by anything?
No.
No. This only happens when you divide by a what? Negative number. And what is it that you reverse? The inequality symbol. Okay? Now, this is where I have kind of a problem with, I've been telling you it's kind of okay if you say equal sign. I really don't like it. And as a matter of fact, from now on, I'm not going to let you say it. It's not a sign. What's a sign?
Negative.
Negatives and positives. What is that equals?
Symbol.
A symbol. And they're totally different. And what happens is, if you let yourself get lazy and say that, and it's not your fault. Remember I talked to you about this. You were probably taught sign, equal sign. It's not, it's a symbol. And what happens is, if you let yourself get into those bad habits, what happens? You always do the bad habit, right? So, here's the way your little brain just picked this up. Irritates me to death, but this. If you divide by negative, change the sign. That's not what it says, is it? If you divide by a negative, it what? Reverses the symbol, right? So is that the same as changing the sign? No. Well, duh. If you divide by a negative, does it change the sign? You bet it does. And anything divided by a negative, a positive divided by a negative becomes a negative divided by a negative becomes a positive, right? Dividing by a negative always changes the sign, but that's not what we're saying here, right? What we're saying is that dividing by a negative will do what? Not change, but what? Reverse the symbol. You've got to be really careful to pick the right language, okay? And it might seem like you can just, oh, well, that's the same. It means the same thing. But it doesn't when it comes time to do it. Okay? So let me show you what I mean by that. Say, for example, you have negative 2x is greater than 4. This is not an inequality. I'm sorry, an equation. This is an inequality, right? But we solve just like they are, just like equations. But do you have any parentheses? Do you have any fractions?
No.
Or decimals? No. Do you have any like terms on each side? No. How many variable terms do you have?
2.
Variable terms? Just one. That's it, right? So it's already on one side by itself. How many number terms do you have? Just one. So it's already by itself. But now, so the only thing here to do is divide both sides by the coefficient. And what is the coefficient here? Negative 2. There's no such thing as a number without its sign, right? So I'm going to divide both sides by what? Negative 2. Exactly. I have to divide by negative 2 because I need the negative and the 2 to divide away. If you divided by positive 2, you'd still have that negative over there, right? What does that leave me with on this side? X. What's 4 divided by positive 4 divided by negative 2? Negative 2. And since it was an inequality, and did I divide by a negative number?
Yes.
What is that going to do to my is greater than? It's going to flip it over or reverse it and change it to an is less than. Okay? So it's really not even math. What's happening is it's flipping it over. The strange thing is, the same thing is happening with the equal symbol as well.
That was my question.
But if you reverse an equal symbol, what do you get? Another equal symbol, right? So you just can't see it.
You don't get not equal to.
No, it doesn't change the symbol. It reverses the symbol. That's why I don't want you to say change. Reverse just means turn it over, right?
So
Flip it over.
It's not turning over to not negative 2?
Well, if you turn that over, that's not gonna. If you turn that over, it just looks the same as it always did, right? If you flip an equal symbol over, right? So that's changing it. See, this is changing it. That's flipping it over. If you flip it over or reverse it, it looks the same. This is change it, and that's another reason I don't want you to use the word change. It doesn't change it. What does change it mean? I'm going to change this folder into a hack. Turns into something different, right? But what if I just turn this folder over? Still a folder, isn't it? Okay? So you see that that's why it's really important to use the right words when you're learning it.
Is less or equal to, so it will change like this too, right? I mean,
Right.
sign-
Any inequality will always just reverse. Okay? Now again, this only happens when you're dividing by what kind of number?
Negative.
A negative. And what did we do really hard when we were solving these? We tried to keep our coefficient, what sign? Positive. And this is one of the reasons. If you can avoid this, then you don't have to worry about it, right? But were you always able to keep your coefficient positive? No. But most of the time you could. Okay? Now, so what we're going to do is we're going to look through a couple of these. And just so that you can, it's pretty much a refresher in solving equations, except for that last step. What if I had the equation 4y is less than or equal to 8? Any parentheses?
No.
Fractions or decimals?
No.
No. Like terms to combine on either side?
No.
No. How many variable terms do you have?
4.
1. The 4y is the only variable term, right? How many number terms do you have?
1.
1. It's just the positive 8. Okay? Is my variable completely by itself? No. I've got to get rid of that 4, right? By doing what?
Divided by 4.
Divide both sides by positive 4. That gives me y on that side. 8 divided by 4 is 2. Does dividing by 2 change the symbol? Or reverse the symbol? Good Lord. No, I got me doing it. Reverse the symbol? No. It just stays is less than or equal to. Okay? Why didn't it change? Why didn't it reverse this time? Because it was positive, right? You weren't dividing by a negative, you were dividing by a positive.
So why didn't you do like, so there's four like positive 4y, so why didn't you like subtract y?
Because what does 4y mean?
I mean minus 4.
What does 4y mean? 4 times y, right? So the opposite of multiply is divide. You can't subtract multiplication, you have to divide it. Okay? So remember, you have to look at how things are put together and then do the opposite. Okay?
I got it.
Good.
But still, it's the positive, right?
Pardon me?
I mean, it's still the positive. I mean,
Right, it's still positive because a positive divided by a positive is positive. Okay? All right. Now, once you've solved an inequality, we can also graph them on a number line. What's a number line look like?
2 arrows.
2 arrows. It's in the middle always.
0.
And then what happens as you go to the right?
1.
They're positive and they get bigger. What happens as you go to the left? They're negative and they get smaller, right? We've seen this before, haven't we? So this is a number line. 0 in the middle. Goes to the right, you get bigger and positive. You go to the left of 0, it gets smaller and negative, right? The numbers are on negative, and then we put that minus in there to note that they're on the left of 0. So what I want to do is look at how to graph one of these inequalities on a number line. Because if you look at this, this says that y is less than or equal to 2. How many numbers are less than 2?
1,
A lot.
2.
Negatives.
1 and 0.
What about all the negatives? What about all the fractions?
Times.
What about all the decimals?
Times.
So in other words, an infinite number of numbers, right? So these inequalities literally have an infinite number of solutions. Well, so are you going to be able to write them all down? No. So instead what we do is we graph them on a number line to demonstrate the answer. So you can't really write them all down, but we can draw a number line that would represent what happens for each one. When you're graphing on the number line, the first thing you need to remember is that there are different inequality symbols, aren't there? Some of the inequality symbols have a piece of the equal symbol in them, don't they? And some of them don't. And depending on if they have that little equal part in them, they're going to get, that depends on what kind of symbol they're going to get on the graph. These two, because they're just plain inequality symbols with no equal symbol, get just a plain parentheses. Plain parentheses just means these things, right? Okay? These two, however, because they have the equal symbol part in them, they need another symbol, and what they get are brackets. Do you remember what brackets look like? What? The squared off ones, right? What are those squiggly ones called?
Braces.
Braces, there you go. Okay? Now, each one of these is going to get parentheses. Either a plain parentheses, can you put the rest of the word on there, huh? Or a bracket. But always get the same symbol. They don't ever change. You're never going to get a parentheses when you need a bracket, right? So you've got to be really careful to use the right symbol. Then, also what you need to know about the parentheses is that it always opens in the direction, oops, let me just write that on the little line, in the direction of the answer. It opens in the direction of the answer. So just to put the parentheses in here, remember on this one that we just did, we have y is less than or equal to 2, right? Just rewrite it here. What kind of symbol would less than or equal to get? A plain parentheses or a bracket? Bracket, okay? And read this sentence to me. It says y is less than or equal to 2. Well, where is positive 2 on my number line here? Right there, right? Okay. And where are the things that are less than 2? Is it going to be to the right or to the left? To the left. The things that are smaller always means go to the left. So, everything that's smaller than 2 is on the left-hand side. So, you see you get a bracket that opens to the left. Do you see what I mean by opening toward the direction? So anytime you're doing these, you're only going to get half of the parentheses or half the bracket. Okay? Now another thing that they always get is shading. You always shade in the direction of your answers. And because this goes on infinitely, I have to shade the arrow too. Okay? So you get a parentheses or a bracket, depending on the symbol, that opens in the direction of the answer. That's the first thing. Second, you always get shading on the number line to represent the answer. In other words, if it says y is less than 2, then you're going to shade to the left. If it says y is greater than 2, what would you do? Shade to the right. Yeah? Okay? Now you have to be careful though and read the sentence carefully. I'll show you what I mean by that. Then, there's a third part of this. We're always going to write our answer also in a different type of notation that you might be used to. We're also going to write it as what's called interval notation. You can do this just by looking at the by looking at the inequality. But the best way to do this is to do the graph first. Because if you do the graph first, then the interval notation for it is really, really easy. Because all you have to do is look at your picture, and it'll tell you what your interval notation should be. Now go back to the graph that we wrote here, this number line. Remember we said that these arrows means that it goes forever to either the right or the left? Okay? There's a symbol for goes on forever, or a word for that. What's the word for it? Infinity. And what's the symbol for infinity? That little, looks like a little S, a little 8 on its side. So we have infinity over here, and we have infinity over here. Have you seen that symbol before? Okay, doesn't matter if you have, it makes no difference. This just means infinity, it means it goes forever. But this one is going forever to the what? Left. And what do we do when we say things are to the left of 0? We use a minus in front of them to indicate that it's to the left of 0. So this one is actually negative infinity. Why negative infinity?
So less than 0.
It goes forever to the left of 0. Good. So that's why it's negative infinity. So this one is what? Positive infinity, because it's to the right of 0. Okay? Yeah, so you have two infinities. You have a positive one and a negative one. Okay? And so when you're using interval notation, you're going to use positive and negative infinity in your answer. Okay? What you always need to remember is that infinity, either positive or negative, doesn't matter, always gets plain parentheses. Because when you're writing your interval notation, you're going to get parentheses around the front and the back. And you need to know which symbol gave you the parentheses. Okay? So let me show you what I mean. Wait a minute, let me write one more thing. It's always read from left to right. Just like we read words on a page, right? So if you're looking at this graph that we just drew, if I was going to read it, I would read it going from this direction, right? Even though the graph points the other direction, you would read it going that direction, okay? So if I'm starting from the left, and here's all my shading. It goes all the way to negative infinity, right? So if I start at the left, what do I get to first if I start from the left? Negative infinity, right? And then I travel along this line that I just shaded until I hit right there. What is that number? Positive 2. And what kind of symbol does it have on it? A bracket. What kind of symbol does negative infinity get? A parentheses. So in interval notation, it would look like this. Parentheses, negative infinity, comma, positive 2, right, because that's where it stopped, bracket. Okay?
But like 2 and 1 is positive, then it goes to minus. But it's still going to be minus infinity.
Because it's forever to the left, right? So it's going forever to the left. Okay? So, let's look at a couple of these. All I want you to do is graph them, and then we're going to write it in interval notation. So say we have, for example, x is greater than negative 2. Now when you're doing these, you don't even have to put more numbers on your graph than the one. This is called the boundary. Okay? So I'm not even going to put all the numbers on my list. All I'm going to put is negative 2. Because that's my only boundary number. I don't care what the rest of the numbers are. So you don't have to put 0 and then write a huge graph. On Course Compass, it will write it for you like that. But you don't have to write a huge graph if you want to. I know that my boundary point is negative 2. Now, in order to know that, the x has to be completely by itself, though. Right? So you may have to solve it first. If the x isn't by itself, can you graph it? No. But in this case, the x is by itself, right? So, I put my negative 2 on the graph, and then I need to know where my shading is going to go. What does this say? X is what? Greater than negative 2. Where are the things that are greater than negative 2?
To the right.
To the right. Now what you can't do, so that means I'm going to be shading forever to the right. Now what you cannot do is say that just because this is pointing to the right, we're going to shade to the right. It doesn't work that way, so be careful. Read the sentence and know, and I'll show you why in just a minute. Now, what kind of symbol does this get? A plain parentheses or a bracket?
Plain.
It's a plain parentheses, and it's going to be opening toward the shading. Okay? And then we want to write it in interval notation. If I'm walking along this way, what do I hit first?
Right.
The negative 2, right? And the plain parentheses. And I'm going to go forever this way. What does forever to the right mean? Positive infinity. And what kind of parentheses does it get? Just a plain parentheses always for infinity. And there's the interval notation. So here's the graph. Here's the interval notation. Okay? So let's look at some steps. First, plot the boundary number. Second, do your shading. Now when you're doing your shading, read the sentence. Don't just shade in the direction of your symbol. That is not how it works. Read the sentence, make sure. Third, put the parentheses in. Fourth, do the interval notation. Okay? So plot your boundary number, then do your shading. To get the shading, make sure you read the sentence carefully. Then put the parentheses in. Find out what parentheses you need. And then finally, do your interval notation. Remember, reading interval notation left to what? Yeah, be really careful about that. You can't just start wherever you want to. You have to start at the left and go toward the right. Now, so I just want to go to your assignment so that we can get some straight from your assignment so you know what they look like. It's pretty slow today for some reason. Okay, so say we have the inequality x is less than or equal to negative 3. First of all, is this ready to graph? How do you know it's ready to graph? It's already solved. The variable x is completely by itself. No signs, no number, no nothing. Right? Good. So, excellent. So what we're going to do first is we're going to plot our boundary number. What is my boundary number in this particular one? So negative 3. That's the only number I'm really interested in. Now in Course Compass, they're going to give you a number. You just put a mark on negative 3. Now I need to know which direction to what? Shade. Now reading this, it says x is what? Less than or equal to negative 3. Where are the things that are less than negative 3?
To the left.
To the left. So we're going to be shading to the left. Good.
You know that's easy to remember?
Don't you say it's pointing to the left. Okay, what is it?
See the little symbol?
Uh-huh.
It's the same as the arrow.
No, don't say that. That's what I'm saying. You can't do that.
That's how I'll remember.
But you're gonna get some of them wrong though. Wait a minute.
No.
Yeah, no, that's what I'm telling you. Hold on a minute. Well, I'll show you how you can do it where that always works if you want me to. I'll show you both ways. Okay. Now, we need to put in our parentheses. Do we get plain parentheses or bracket?
Bracket.
Why?
Because it's the left.
Because it's got that little equal symbol under it, right? That always tells you get the squared bracket. Then, we need to do our interval notation. Walking from the left here, so what do we see first? Negative infinity, yeah. So negative infinity, which always gets a plain old parentheses. And we walk on until we get to here, and that's where the shading stops at what number? And it gets a bracket. It has a bracket on the graph, it gets a bracket in your interval notation. Now let me warn you, for some reason that I'll never understand, and I cannot change it, I cannot fix it, and I've written plenty of times to complain, they always have you do the interval notation and then do the graph. Don't. It's easier to do the graph first, and it'll let you in Course Compass. Do the graph first on paper, and then you can do the interval notation. Because here you'd just be pulling stuff out of your head. here you're looking at a physical graph. You've got a picture of it, so it's a lot easier to read that to tell me the interval notation. Now, if you can do the interval notation first, great, that's fine, I don't care, but I'm just telling you that it's a lot easier to graph it first. So graph it on paper and then answer the questions, okay? Trust me. All right, let me show you why watching just the pointed thing is a bad idea. Okay? Sorry, it sounds like a great idea, and on all the ones we've used so far, it really works. But say we have -2 is greater than or equal to x. Now, the symbol points this way, right? So you would think that it would be -2, and that gets a bracket, right? And you'd be wrong. What does this say? This says -2 is bigger than our x, doesn't it?
Yeah.
So that means this point right here is bigger than my x. So where should my shading be, actually be?
Left.
To the left.
Bear.
Okay? Yeah. Now, but I'm going to give you a way to be able to always use that pointing rule if you want to. Okay? What you can do is, we did this in another lesson, we can write the equivalent form of this. In other words, just reverse it. But remember, if you reverse one thing, then what?
Reverse everything.
So, if I put the x on this side and the -2 on this side, what's that going to do?
Space. Oh, change also.
Right. You can reverse everything, but if you do, you have to reverse the symbol. Now you can use that points in the right direction thing, right? But only if the x is where? On the left side. That's another reason your little math Nazi high school teachers wanted it on the left-hand side. Okay? Because then you could always do the pointy thing and they never had to explain to you why. Okay? So, do you see that? You can do it either way you want to. If you want it,
With your bracket. Alright, never mind, just figured out.
no. What do you mean?
If you don't do the swappy thing,
Right?
is your bracket correct right now?
You bet.
Okay.
Because -2 is greater than or equal to x.
Right,
Right. I had it backwards the first time on purpose, but now it's right.
okay.
Okay? All right. So you can either reverse the inequality first, but if you do that, you have to reverse the numbers and the x's and the symbol itself too. Or you can just read it. -2 is bigger than x. That means x is the little thing, right? The smaller thing. So be careful. Remember,
The answer is
okay, so here's the graph. Now how do we do our interval notation? What is it going to be? Huh? Parentheses, -infinity, right? Infinity always gets parentheses. Then -2 with a bracket. So there you go. Okay? All right. Now, it's new. Deal with it. You'll be fine. Okay. The only thing else that can happen to you is that you could have problems where you have to solve the inequality first. And what does solving the inequality mean? Get the x completely by itself by doing the opposite operation. And the only thing you have to watch for there is that when if you do what?
Divide by a negative.
Divide by a negative,
Reverse your symbol.
going to reverse the inequality symbol, right? Okay. All right, so that finishes this chapter. So what we're going to do is we're going to go to the lab, we're going to work on our homework, and then next time we meet, we're first going to review for the test, and then we're going to take the test.
On that day?
Thursday.
So, on Thursday. Now, because we just simply don't have time anymore